Again, we stopped the previous video sort of in the middle of an example. Have backed it up just a few seconds so that we could pick right back up with that. Again, the example is going through and doing the calculation for the Wilcoxon matched pairs, or related samples, or whatever they want to call it, test. Again, the important thing is that you could do this analysis with the t-test, but for some reason the samples are non-normal or something like that. The t-test is not an appropriate test, so you fall back to the non-parametric test just so that you can make sure that you get the analysis done. Okay, so let's join back up with the pre-recorded video at this point. The 3 and the 4 to get a 3.5. Continue all the way down. This last number, 14, should match up with the sample size. Unless it's tied. If it's tied, then it'll be an average of the next number previous to that and this one. Then we take the sign and we go through and we calculate the signed ranks. So this had a rank of 1, it was positive, it was positive 1. This had a rank of 2, it was negative, so it's a negative 2, negative 3.5. Again, negative 3.5. Positive, here's another negative down there, negative 10. Then we add up, and we're interested in the smaller of the ranks. So we go through and we add these up, and we find out that our test statistic is 19. So that comes from this 10, these minus 3.5 minus 3.5, that's minus 7, and a minus 2. You add all those up and you get a minus 19. We're just interested in the positive part of that. And then you can take and you can look that up in the table at 14, and the 19 value is between a 0.01 and a 0.025. So that's a 19 is actually over here. I'm sorry. No, it's here. Where am I? There's 14. The sample size is 14, so it's between the 16 and 21. So somewhere between a 0.01 and a 0.025 would be the significance level of that particular test. Okay, the next test I'd like to look at is a Wilcoxon test for independent samples. Sometimes you'll see it called the Mann-Whitney-U. Sometimes it's going to be called the Mann-Whitney-U Wilcoxon test. There's just several names for it, so be ready to see a bunch of them. But it is the parametric equivalent of it is a t-test for independent samples. Basically, to do this one, you go through and you rank the values from both samples, and then you total the ranks from each sample. Theoretically, if the samples were equal, then those ranks would be relatively equal. If they're not, then you're going to expect some differences. Just a little bit of a graphical example here. We have a group 1 and group 2. You can see that these guys are sort of down here and these guys are sort of up here. So you'd sort of expect to see a difference between those two. So that's just, if we were to rank these, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so you'd have the higher ranks in this group and lower ranks in this group. So let's look at some data. We have 3 in this group and 5, 6 in this group. We put the groups together. We want to keep up with which group they came from. That'll be important to us. But we go through. Here's a 23. So it has a rank of 1. there's a 28. It'll have a rank of 2. The 29 will have a rank of 3. The 38 will have a rank of 4. And then the rest of these will go over here. But you can see that how you combine them all together and then you rank them, but you keep up with them. The sum of the minimum ranks, minimum, is going to be 1, 3, and 4. That's going to be 8. And some of the major ranks will be all these other numbers, 2, 5, 6, 7, 8, 9. That's going to be 37. So then go through and you do your test. We had a sample size of 9, and one-sided test, if we have a value of 8, then it is significant at the 0.05 level. So this would be a significant value. So you can see that the calculations on these is actually relatively equal, or relatively easy. Sorry about that. Let me, there's lots of programs out there, and let me just switch over to one here and see if I can show you. That should bring it up. The Wilcoxon 2-sample test, if we just go through and we'll put these values in that we had, 23, yep. Okay, let's try this again. Okay, apparently it looks like I had some challenges with getting that program to work. We're at the end of this session, pretty close anyway, so let me just go ahead and stop here. I'll see if I can get the technical issues taken care of, and then I will get back with you. One thing I do want to emphasize is that with the non-parametric test, in the demonstrations, in the examples that I give, I am using small samples. I'm not trying to say that small samples work better with non-parametric test or anything like that. I'm just using the small samples so that you can, so that we can see some examples of the program or how it works, the problem, how it works without getting too involved in the calculations. So I'm just using small samples just for the convenience of the sample size. So anyway, I'll end this, and then we will get back with you and